Test solution to trigonometric identity. So this is one of the questions from the test. It's question number 5 from the test paper. Now some of the students have not really done compound angle formulas, right? So for them, well, this should be counted as out of course, right? But most of you have done. So let me tell you sine a plus b formula, and let me just give you straight what is sine 2x, right? In general, sine 2x is equals to 2 sine x cos x, and cos 2x actually can be written in 3 different ways. It is equals to cos square x minus sine square x. It is also equals to, if I write sine square x as 1 minus cos square x, then I get 2 cos square x minus 1. But if I write cos square x as 1 minus sine square x, in that case I get 1 minus 2 sine square x, right? Now this particular question is very beautiful and it utilizes all these formulas, and that's the beauty of this question, okay? So let's look into this solution now. So what I'll do is that now I have option of cos 2x. I could write any one of these. Now since it is 1 minus cos 2x, I'll prefer to write here in the form of sine, so that if I write 1 minus sine square x, 1 and 1 will cancel out, right? So that is an advantage, correct? Or think like this. I can bring 2 sine square x on this side and say 2 sine square x is actually 1 minus cos 2x. So that way I get only 2 factors here and 2 terms here, and that helps to simplify. So that is a kind of strategy. So I'm going to use on the numerator side 1 minus 2 sine square, and in the denominator I will use 2 cos square x minus 1. Okay, so let's start with the left side, and now I'll do 1 minus, so instead of cos 2x I'm using 1 minus 2 sine square x. So this is 1 minus 2 sine square x plus sine 2x is 2 sine x cos x. Divided by 1 plus, and here I'll use 2 cos square x minus 1 plus 2 sine x cos x. Well, you could use any combinations, but that gives you the solution in minimum number of steps. And it's kind of important to do your solutions in minimum number of steps. It saves time, right? Now 1 minus 1 is 0, but minus of this gives me 2 sine square x plus 2 sine x cos x. Divided by, here 1 minus 1 is 0, we are left with 2 cos square x plus 2 sine x cos x. Now in the numerator we can take 2 sine x common, and in the denominator we can take 2 cos x common. So we have 2 sine x, we are left with sine x here plus cos x, divided by 2 cos x, and we are left with cos x plus sine x. Now this cancels out, 2 cancels out, and so what do we get? We get tan x, right? Which is the right side. So hence proved, left side equals to right side, and identity has been proven. Okay, so this is kind of a critical issue. If we don't do that, if we start with cos square x minus sine square, we may take a step longer, but then still it can be proven. Okay, thank you.